maybe with another 2 minutes or 3 minutes, okay. Then we will start our class, okay. So before that, let me show you the list of the group for the assignment. Okay, you can check your name, right, and then also the title, all right, so that you are chosen, all right. For example, like group 1 number 1, okay, you choose question number 4. Okay, group number 2, you choose question number 3. Group number 3, you choose question number 2, and group number 4, you choose you select the question number 1. Okay, so and then you have another 3 group. Don't select the title. Okay, after this you can update to me. So maybe group number 5, maybe you can select question number 5 or 6 first. Then we can rotate. Okay, please make sure all the title will be selected. Then we can rotate lah. Okay, for example, like group number 5, maybe you can choose either number 5 or question number 5 or number 6. Okay, and also group 6. Okay, then 7 and 8, so maybe you can choose or if group 7 you want to choose first, okay, up to you. First come first serve, right? Okay, and then we have another, I think we have another one group lah, still not submitted the group, okay, the group members, because of the totals, okay, the total of our class, okay, is 37, all right, 37. Now currently we have 33 students. I think we have short one group lah, another one group, so that means we have 8 group for this assignment. Right, and then the group number 5, 6, 7, and 8, please update your question, okay, your the title that you choose. So we have already explained last week. So we have 6 questions. You have to choose only one. Okay, I think some of the group already started the assignment. So that's good. Okay, so on the software part, some of the group. Okay, so when you do the fill-ups table, let me refresh what for the assignment. So for the fill-ups, first is the facts. Second is the okay, ideas, okay, learnings, issues, and the action. So normally the action, you are just focus on the digitals, okay, on the digital electronic lah. On the, for example, like for beyond on the digital electronic.
Alah, bodoh cinta.
Okay, guys, please silent your okay, silent. Please mute your your mic. Okay, I think so now we are 5 minutes. I think we can start. Okay, we can start our lecture for today. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to all of you. All right, so now we have 25. Okay, we have 25 students. Okay, so let's start our lecture. So today we go for the new chapter number 4. Chapter number 4 will be on the sequential circuits, and the flip-flop actually is a similar like conventional circuit, but there's something different that I will explain after this. Right, and then this is a learning objective. Okay, the learning outcome for this topic. So at the end of this topic, you should be able to describe the operations and the use of latch and flip-flops. Okay, latch and flip-flop is the one is the sequential circuit lah. It's a sequential circuit. So such as we have the SR. Okay, we have SR latch or flip-flop SR. So SR is this one is we call the set and reset. Okay, this one is a set and reset, and then we have D. okay, the D latch or D flip-flops. Okay, D normally it can stand for data, or some of the refer to the delay. Okay, delay. And then we have T flip-flops, or T is a toggle. And then JK, I forgot the stand for what. I think that the JK is based on the name. I will check after this. So normally we have a SR, okay, SR flip-flop or SR latch, okay, and then we have the D flip-flops. The D is for data or for delay, and then we have the JK, and then we have the T. Right, and then second learning objective, learning outcome. So at the end of this topic, you should be able to draw the flip-flop logic symbol, all right, and then draw the timing diagram, okay, based on the flip-flop operation. It means based on the SR, okay, SR flip-flop, or D flip-flop, or T flip-flop, or JK flip-flop lah. And then you have to recognize the difference between the latch and flip-flop. So what is the difference between the latch and flip-flop? Before that, you have to know what is the difference between the conventional logic circuit and the sequential logic circuit. After that, I will explain to you lah. Okay, and then to understand the flip-flop operation characteristics, then last but not least is the apply flip-flops in the basic application lah. So we try to apply flip-flop in the simple applications. So this is the learning objective, the learning outcome of these topics. Okay, topic number 4 is the sequentials and the flip-flops. Okay, so before we go for the sequentials, okay, sequential circuit, we have to know what is the difference between the combinational circuits and the sequential circuit. Okay, for the conventional circuit that we are studying before this, we are studying about the combinational of the logic gate, such as we have the AND, we have the OR, we have the exclusive OR, we have the NOR gate, we have NOT gate. So we can combine, so that we call the combinational logic circuit lah. Okay, so this characteristic of the combinational logic circuit, you can see here. So the output depend on the inputs. Okay, the output here. Okay, for example, X here actually is the depends on this one, depend on the inputs. Okay, and then no feedback. So this one is no feedback, just depends on the inputs. Okay, the output. Okay, this output, the X here will be depends on the value of A and B lah. Alright, so either is a plus or minus. Okay, so depends on the circuit here, on the conventional circuit here. Alright, so but it's no feedback. Okay, no feedback here. So that is we call the conventional logic circuit. And then enables to remember the past value. Okay, so that means we don't have memory. Okay, this one only the present value lah, for the present input. So for example, input 1, we have the 1 0. So for the next, we have another input. Okay, for next state. Okay, for the next state, we call the next input. So the output depends on the present input lah. Okay, so because of the conventional circuit, we don't have the memory. Then for example, logic gate is for example like AND, O, NOT, and so on. So you can see this guy. So actually this is a conventional circuit. Okay, but this is not sequential. So next we go, what is the sequential? Then you can see what is the difference between the combinationals and the sequential. Okay, for characteristic of the sequential circuit is the output depends not only on the current, okay, on the present input, but also on the past output. Okay, either is the new input value lah. Okay, you can see this one. Okay, actually in the conventional here, so in the conventional circuit here, but for the sequential we have this one. We have the storage element, and we have another one is the feedback. That is the difference between the sequential and the combinational circuit. Okay, that means so the output, actually this output depends on the input and also the pass. That means we have the feedback lah. So the output from the system is feedback as the new input here. So either we can use this input, or we can use the feedback here as the input. That we call the feedback lah. So that means for comparison between the conventional and the sequential is the one is the feedbacks, Okay, depends. That means the output depends on the inputs, present input, or it depends on the past output lah, that we call the feedback. And another one is the storing. Okay, storing binary information is memory. Okay, it's this, for example, is the next state, and then we go for the present state lah. So the difference between the conventional is the storage element and the feedback. Okay, and then some example of the sequential is the latch. Okay, latching, flip-flop, and the logic gate lah, the combination of the sequential circuit. Sorry. Okay, guys, please mute your mic first. If you have any question, you can on your mic. It's okay, and then you can stop me if you have any question. All right. So the content of the storage element here we call the state lah. Okay, for state. Okay, the next state, present state, and so on. Okay, so this is the sequential circuit lah. So on the sequential circuit, we have the combinational circuit here. We have the storage and we have the feedback. That is the difference between the combinational circuit and the sequential circuit. The combinational circuit only we have the input and the output. Okay, all right. So no memory, but no feedback. I mean, okay. On the sequential, we have the feedback here, and also we have the storage element lah. So the example of the sequential like latch here, latch, or we call a flip-flops. Okay, something we call latch or flip-flop lah. For example, like okay, our switch. Okay, our switch. That's why we call a latch. Okay, something like some the other definition is that like holding the circuit. Holding. That means when you press the push button. Okay, so the circuit will be on. And then after you release, but the circuit still on. That means we call the latch. Okay, the latch circuit. Oh, that means hold the circuit. Okay, we hold the circuit until you press the push button. So your circuit will be off. That we call the latch, or something we call the holding circuit lah. Similar like this one. We have the latch. Okay, and then we have the flip-flop lah. Okay, so for the sequential circuit, we have two types lah. Okay, two types of the sequential circuit. So the sequential circuit depends on the timing diagram lah. We have two types of the timing diagram that you have here. You can see here. So first is the synchronous, and second is the asynchronous lah. So you can see the difference between the synchronous and asynchronous. Alright. So for synchronous, state change synchronous by the clock. That means here we refer to the clock lah. So yeah, when before this, when we remember here, so this is our clock. Okay, something like this. I think this not nice, right? But the clock is nice lah. Okay, something like this. All right. So actually, this synchronous depends on the clock. Either you can start on the positive. Okay, here positive edge or negative edge. Okay, if you start on the positive edge, that means this will be triggered on the positive lah. On the positive. Okay, so the clock will be on the positive edge trigger. If you refer to the negative, for example here we refer to the negative edge trigger, that means from 1 to 0. That means all the output will be referred to activate on the negative. Okay, make sure you have to remember here. So I will show after this what how to when you use positive edge trigger or negative edge trigger. Okay, for the synchronous. Okay, synchronous sequential circuit. And then next, easier to analyze because of can factor out the gate delay lah. So this one we have the some delay. Okay, and then next set clock. So change. Okay, so change allowed to occur before the next pulse. Okay, and then this is the characteristic on the synchronous. For asynchronous, okay, change occur independence of the clock. So that means here don't depends on the clock. Okay, so just depends on the sub input. Okay, that is the difference between the synchronous. Normally we refer to the clocks, and this one no clocks. That means we can refer to the input. Okay, some input lah. And then potentially is faster than synchronous. Okay, but it's harder to analyze. Comparing synchronous is easier to analyze, but for asynchronous very hard to analyze. Okay, that is the characteristic of the synchronous and asynchronous. That means we have two type of the sequential circuit. Either we use the synchronous, that means we have the clock, okay. The synchronous refer to the clock, and asynchronous normally it depends on the input lah. Okay, so this some example. Okay, so the clock. So this one is a mistake. The on suppose it's a clock timing of the waveform. All right, so we have two types: synchronous. Okay, output change either at the rising or falling edge of the clock lah. So this one. So this we call the positive. So sometimes we call the rising. Okay, this one will be falling lah. Okay, this one we call positive. Okay, normally I refer to the positive edge trigger here. Positive edge trigger, and then this is positive edge trigger, and then this positive edge trigger. For negative edge trigger or falling edge here, so will be activate here. Right, so this one we call the clock lah, so will be synchronous. Okay, that means 0 1 0 1 0 1. Okay, this one will be synchronous. For asynchronous, maybe the clock will be not, because of normally it depends on the inputs, it not depends on the clocks lah. So normally clock will be synchronous lah. So it will be 0 1 0 1 0 1. So and then depends on the circuit, either you focus on the rising or the positive edge trigger, or you focus on the falling edge trigger lah, or negative edge trigger. This one normally I refer to the negative edge trigger. That means from 1 to 0 lah. For positive, from 0 to 1. Okay, so this is the sequential circuit. So you can see this is a plus. Okay, this is a clock pass. Okay, and then this is our combination circuit, and then this is the we call the flip-flop. That's the memory. It's the memory. Actually, the latch or the flip-flop basic storage element. So you can see the previous slide. So actually, this is the we call the storage element. Okay, storage element. So the storage element can be flip-flop or can be latch. Okay, so that can operate with the signal level, with the inputs. Okay, either can operate with the input or it depends on the pulse. Okay, so this is the simple example of the pulse. Okay, normally pulse is the synchronous pulse. Okay, so we have the synchronous clock. Okay, next we go for the latch. Okay, so latch and flip-flop actually is almost similar. Okay, actually the both is the basic storage element lah. So but they have a different of type lah. So the concept will be almost similar. Okay, we will compare latch and the flip-flops. Okay, for latch we have two stable state. Here, digital circuit that produce high and low depends on the inputs. Okay, high and low, that means 1 or 0 lah. 1 or 0 depends on the inputs. Okay, for gated, okay, so gated here enables latch, so the output controlled by enable input. Okay, so for the gated latch, okay, gated latch, so normally the output depends on the enable. So when the enable is active, okay, active depends sometimes depends, we call the active low, sometimes you can active high. Okay, active high, that means will be 1. Okay, maybe active low, maybe we can declare as the 0 lah. So the output depends on the enable input. So when our enable input is active high, so that means the output will be depends on the enable input is high. Okay, for example, after this we go for the example. So it is level trigger lah. That means any input change during the enable is active. Okay, this one active at the active high or active low. So when active high, that means will be active at 1. Okay, if this one is active low, that means will be active at the 0. At the 0, so the output will be affected lah. Okay, and then the output will be changed depends on this enable inputs. Okay, the operation will be observed by examining the timing diagram lah. Alright, so the timing diagram. Okay, so this is a type of latch. Okay, so we have 4 type of latch. We have the SR latch. Okay, normally SR is the NOR gate latch. Okay, NOR gate latch. So inside this one we have the NOR gate lah. After this I will show the digital circuit here. All right, so normally SR is the set. Okay, normally it's a set and reset. Okay, set and reset latch. Okay, so it's the NOR gate latch. Okay, and then S bar R bar latch is the NAND gate lah. So okay, inside this one is we have the NAND gate. Okay, we have the NAND gate, right? And then we have the gated SR. Okay, so that means here we have refer to the enables. Okay, we have to refer to enable to get the output. So the output will, when this enable is active, then the output will be active lah. Okay. Last is the we have the gated D latch. Okay, D latch also refer to the enable lah. So when enable is active, then the output will be effect based on the enable input here. Okay. There's for the latch we have four type lah. Four type. First we have the NOR gate latch. Okay, or sometimes we call the SR latch. Okay, and then for NAND gate latch we have sometimes we call the S bar R bar. Okay, latch. And then we have the gated SR latch. And then okay, so the gated normally it depends on the enable input. Similar like gated D, gated D that I mentioned to you is the data, or sometimes refer to the delay lah. Okay, the delay. That sometimes refer to the data, sometimes refer to the delay. Let's okay. That means the output depends on the enable here, enable input here. Okay, so now we go for the one by one. What is the SR latch? Okay, so inside this one, you can see this one. This is a NOR lah, dimension to you. So this is something like this lah that you can see. That's why here will be. So this is a logic circuit inside the SR latch. They have the NOR gate here. We have two NOR gate here. So this is a symbol for SR latch. Okay, you have to remember here, right? And then this is truth table that you have to remember. The truth table for simplicity, you have to remember this one, so no need to go for the operation of the one by one. After this, we have go one by one. So if you remember this one, remember the truth table. So you can use this truth table to solve the problem or using the SR latch. Okay, for example, like this one. Okay, you can see this one input SR. Okay, so normally the Q bar will be inverse the Q lah. So we just focus, normally we focus on the Q. Actually the Q bar is invert from the Q. Alright, so for example, if S0 R0 here, so we have no change. Okay, no change happen. So that means follow the previous. Okay, follow the previous. For example, the previous is 0. Okay, for example, the previous is 0. Then no change, so automatically will be 0. Okay, if the previous is 1, so no change, the output will be 1. It's no change. Okay, no change. Depends on the previous value lah. So that's why we call the no change. Okay, if S0 R1, all right. So that means we activate the R. R is the reset. So that means we have to reset our output. Okay, for example, our output now is a 1, so you have to reset, so will be 0. Okay, for example, will be 0. That's why the output will be 0 here. If 0, that means if you are reset, will be 0 lah. Okay, no need to change. But if the previous is the 1, so if you get the S0 1 R is 1, so that means we have to reset the output, so will be 1 to 0 lah. Okay, that's why the output here will be 0 here. And then if S is a 1 here, okay, here will be activate lah. Okay, will be activate, S will be activate. That means will be set. Okay, there will be set. That means the output will be 1. The output will be 1. That's why the operation here will be set. Okay. So for example, previous is a 0, so will be set will be 1 lah. If 1 will be 1 lah. Okay. So no change lah because of the already set. Okay. And then but if S is 1, R is 1, so this is we call the invalid operation lah. Invalid So so the output will be 0 lah. The output will be 0. Okay, the output will be 0. Invalid. We call the invalid lah. Invalid operation. Okay. So here is the truth table. Okay, this is the we call the excitation table. Is the we refer to the next. Okay, the next state. Okay, so for example here is the current. Okay, is the current state, and then this is the next state. Okay, for example, this is 0 0. Okay, for the next state it will be 0, and then this is the possibility. All right, so at 0 for S is 0. For R is the don't care, either is a 1 or is a 0. Okay, so that's why we put a X here. So either it can be 1 or it can be 0. Okay, that's why we put X here. So you have to remember the excitation table lah. And then for next is a Q is a 0. Okay, but the next state will be 1. Alright, so this is the for the output. Okay, for the input for SR. Okay, 1 0. And then for the next, for example, we have the 1, and then for the next state, okay, the next state for the Q will be 0. So this is the input for SR. Okay, so this is we call the excitation table, and this is the truth table. So you have to remember the truth table here, the operation. For example, if SR is 0 0, that means no change. We will follow the previous. Okay, and then when R is 1, that means we will reset the output. Okay, and then if S is a 1 and the R is 0, that means will be set. Okay, it will be 1. And then if a 1 1 for R and S, so will be 0 lah. That means we have the no invalid. Okay, invalid operation. Alright, so this one will be okay. You can see this one. So this one I will skip. So this one actually is the operation of the state. The will be explained on this part. On this part. Okay. First will be explained on the no change, the operation on no change. Okay. Next for the reset, set, and invalid lah. So this one you can read after this, right? So maybe we go for the example. Okay. So this one is the invalid, right? Next, we explain on the Terminogram. On the Terminogram. Okay. So this is a truth table that similar like for this truth table. Okay, this is the for example this is some example. All right, you can see here. So for example, if S is a 1, R is 0, S 1, R 0, that means will be set. Okay, will be set. That's why here will be 1. Okay, here 1. All right, so next you can see next next here. Okay, S 0 1 R. Okay, here. So will be reset. So that's why here will be reset. Okay, and then 0 0. Okay, 0 0. Okay, 0 0. Okay, S0 R0 0. No change. Okay, no change will be follow the previous. So previous is a 0. So this one will be 0. Okay, then next. Okay, next R1, and then this 0 S0 actually is the reset. So now already reset again, already reset because of the 0 here. All right, so this one automatically will be 0. Okay, suppose this one if the previous is 1, so if the reset, so this means here will be 0, but the previous is 0, so no need to reset lah because of the already reset before this. So just put here so we follow the previous. All right, will be 0. Then okay, next S1 R0, that means will be set. Okay, will be set lah. Okay, here. Okay, S1 R0, this means will be set here. Okay, so that is the output for Q. So 1 0 0 0 1, and then for the Q bar, just invert lah. Just invert the input for Q. So this one will be 0 1 1 1 0. Okay, so normally we just focus on the Q lah. So normally the Q bar will be invert the dimension period, will be invert the Q. The Q bar will invert the Q. So you have to remember this one lah. Okay, the operation here. Okay, and then the operation, and then the okay, maybe I put another example here. Okay, so we have, okay, for example, we have the 1. Okay, for example, okay, this is for S. Then okay, Okay. Alright, for example, right, so this is for R. Okay, then find the Q. Alright, the first step you have to know here. So 0, first step is a 1, 1. Okay, 1, 1 is the invalid. Okay, invalid operation. So will be 0. Okay, this one. Okay, I will write like this. Okay, so with this step is the 0, okay, because on 1, 1, invalid operation. Okay, next, 0, 1. Okay, 0, 1. 0, 1, this means will be reset. Okay, will be reset, and because R will be activated, will be reset. So normally before this already reset, so just this one will be continuous to follow the previous is the 0 lah. Okay, 0. And then next is the 0, 0. Okay, 0, 0, no change. Okay, no change. So will be no change. Okay, will be 0 here. And then next will be 1, 1. Okay, 1, 1. Okay, S1, R1. So will be invalid. Okay, invalid. So will be 0. Okay, so this one also 0. Okay, last one. Alright, so last one, 1, 0. 1, 0 will be reset. So will be 0. So this is the output lah. Output for Q. And then for Q bar will be this one will be 1 lah. Okay, will be 1. Right, so that is the example, another example here. So based on this table, you can write the output lah. You can draw the timing diagram for the SR latch. So this you have to find the Q, and then normally the Q bar will be invert the Q lah. Okay, so this is some example of the SR latch. Okay, next we go for the NAND gate. That means S bar, R bar latch. Okay, so it's a similar. Okay, but we just use the NAND gate inside this table, the symbol here. Alright, so inside this one actually is the NAND gate lah. Similar like before this using the NOR gate. So now for the S bar, R bar latch, so we use the NAND gate lah. So this is a symbol. You can see the difference is here. So we have bar here, bar R, S bar, R bar, and so another one here we have the bubble here. Right, so that is the difference between the symbol of the NAND gate and NOR gate. So we have to remember. So the difference here. So for example, okay, you can see this one. Okay, so no bubble here. No bubble for SR latch, no bubble here. Okay. All right. So but for the NAND gate, we have the bubble. So that the difference between the NAND gate and NOR gate lah, or SR gate and S bar R bar latch. Okay, so the operation will be different lah. Okay, there will be almost similar, but will be change the input and output. So you can see this one. If 1, 1, 1, 1 before this for SR, so this one 0, 0. That means no change. But this one is the 1, 1. Okay, 1, 1, no change. The operation will be no change. That means follow the previous lah. If the previous is 1, so the current value will be 1 lah. If the 0, so the current value will be 0 lah. So if 0, 1, S0, 1R will be set. Okay, will be set. Okay, that means compare before this, if S1, R0 will be set, but for this one will be inverse lah, inverse with the SR latch lah. So this one, if 1 here, so automatically will be reset lah. Will be set. Okay, will be set, and then if S1, or normally this one will be activated. So this is we call the active low here, So that means 0 will be activated lah. So that's why it will be activated on the set here, and then also this one will be activated at the reset. Okay, that's why if S is 1, R is 0, that means will be reset. Compare then if you use the SR, so SR here is the S1 will be set. Will be set for SR latch. For S bar, R bar will be reset lah. So for 0, 0, okay, for 0, 0, that means will be invalid. Invalid, but the output will be 1. Okay, invalid, but the output will be 1. Compare then SR latch. Okay, if 1, 1, Okay, 1 is an invalid operation, but the output will be 0. Okay, the output will be that the difference between the NAND gate and NOR gate that you have to remember lah on the truth table. Okay, the truth table for the NAND gate and NOR gate. Okay, for the latch. Okay, so this is operation similar like SR latch. Okay, they explain on the every part. Okay, every operation, no change. Okay, set and reset. This one after you can go through. Okay, just skip this one. We go for the Terminogram. All right. So the Terminogram for the NAND gate. All right. This is some example. Okay, you can see this one. For example here. Okay. For example, we have the S1, R0, S1, R0, S1. Here R0. That means will be reset. Okay, will be reset. So that's why the output here will be 0. Okay. Next 1, 0. Okay. R1, R1. 0 will be set. Okay, will be set. The output will be 1. So that's why you can get here 1, 1. Then next here 1, 1. So 1, 1, no change. Okay, you can see this one, no change. So the previous is the 1. So this no change. No change. Okay. So normally we follow the previous. Okay, follow the previous. If the previous 0, that means no change will be 0. But here previous is the 1, so no change, still 1. All right, and then 1, 0. 1, 0 will be set. So will be set. So before this already 1. So set will be 1. So it will be reminder will be follow the previous. Okay, and then next. All right, 0, 1. Okay, 0, 1. R0. Okay, S0 will be reset. Will be reset. So that's why reset will be 0. Alright, so and then for the Q bar will be invert the input, the Q lah, invert the Q. So 0, 0, 1. Okay, so maybe you go for the another example here. 0, 0, 0, 1. Okay, just simple example. Okay, 1, 0, 1. Okay, this is for R, this is for S. Alright, so what is the output here? Okay, the output Q, right? So for example, first 0, 1. Okay, R 1, 0. So will be set. Okay, will be at the 1 here for the Q. Okay, and then 0, 0. Okay, 0, 0, 0, 0, invalid. Okay, 0, 0, invalid. But the output will be 1. So will be 1 here. Okay, will be 1, 1. Alright, and then next 1, 0. 1, 0. 1, 0 will be set. Set. Okay, previous is a 1. So we maintain 1. And then last 0, 1. Okay, 0, 1. 0, 1 will be reset. So output will be 0. So that's the output. Okay, so will be 1, 1, 1, 0. And then for Q bar, we invert the Q. So will be 0. Sorry, something like this. Okay, right. Invert the 0, 0, 0, 1. Okay, so the Q bar will be invert the Q. So this is another example for the using the NAND gate. NAND gate. Okay. Next, we go for the gated. Okay, gated SR latch. Alright, so you can see the difference between the SR latch and the gated. So we have here. So we have the enable input. So the output here actually depends on the enable input here. Alright, so this is a symbol. You can see like this. Okay, inside the okay, inside this symbol, so we have the circuit here. So we have the gate here. So we have the NAND gate, and also we have the we have the NOT, and also we have the OR gate here, right? So this is a truth table for the gated SR. All right, so you can see, for example, if you use the active high, okay, active high, that means it will be active 1. So you can see this one. So when enable is a 0, that means the enable is not active. It's not active. Either you put that's why you can put X here. So either can be 1 or can be 0. Either can be 1 or can be 0. Right? So that's why we put the X here. can be 1 or can be 0, it can be 1 or can be 0. So you can see no change. So no happen. So no activate. Okay, follow the previous. Okay, that means no activate. The output will be no change. Okay, because of the enable input is not active. Okay, not active. So when we the enable is active, that means active height here. Alright, so when we enable is the 1 here, so then we have the operation here lah. Okay, for example, if S0 R0, that means no change. The operation will be no change. Okay, if similar, this one actually is a similar like SR latch. Okay, SR latch similar. Okay, the operation here will be similar. Okay, you can see will be similar when the S, okay, S is 1, that means will be set, alright, and then will be 1 1 will be invalid, but the this part will be will be triggered based on the enable input, based on enable input here. So when we this active, okay, so then the operation will be similar like SR latch lah, okay, but okay, if not active, so will be no change. Okay, and for example, the here will be 0 0. Okay, for example, the enable is still 0, so no change happen lah. So no output will be no change. For example, the previous is 0, so the current state will be 0 lah because of no change. Okay, because of the enable input still not active. Okay, that's the difference between the gated. Okay, we call it gated, and then the SR latch. Okay, so the operation actually is the same, but the difference on the enables. Okay, actually this depends on the enable input. Okay, so this some terminogram. All right, so maybe some example lah. I will show you some example here. All right, so you can see this one. Okay, so and then this actually is a 0. You can see this one is not activate. That's why everything here you can put as a 0 because the previous assume as a 0, so we put as a 0. Okay, now the enable will be active here. Okay, will be active here. Okay, so and then just follow the SR. SR that means S is 1, R is a 0 will be set. Okay, will be set. That's why you can get here. It's a 1. Okay, 1 until for the next. Okay, the next actually here. Okay, you can see this one. Actually is a 0. 0. If a 0, okay, you have to remember if a 0 there is the no change here. No change. So that's why here, okay, this from this position to this position will be no change. That means will be okay, this one will be 1 and then follow the this one will follow the previous. So if the previous is 1, so this one will be 1. Okay, if the previous is this one is a 0, that means will be this one will follow the previous is a 0. Okay, until that's why you can get until this one will be 1 until this part. Okay, so will be active. Okay, enable this active here. Okay, 1. Okay, now we have the R is 1 and then S is 0. This means will be reset. Okay, reset. So reset will be 0 lah. Okay, reset will be 0. So that's why here will be 0 until this part. Until this part will be 0. Okay, so you can see this one similar like before this. Alright, so this is not active here. So enable is not active. So anything have on the SR, so no change. Okay, so you can see so this one can be 1, can be 0. This one can be 1, can be 0. That's why if enable is a 0, so everything just follow the previous. So the previous is a 0 here. So this one will be 0. Okay, will be 0 until this part, until the next. Okay, the next enable active. Okay, until this one will be 0. Okay, so now the enable will be active here. Okay, so R is 0, R is 1 is a set. Okay, so that's why you can get here. Okay, 1, and then this is still active. Okay, right, so you can see this one 1 0, so we reset, so that's why you get 0 here. Then 1 0 1 0 will be set. Okay, will be set, so that's why you can get here. All right. So that is the output for the Q. For the Q bar, so just invert the Q lah. Okay, something like this. So this is the Q bar, right? But you have to know how to get the Q. Okay, after you get the Q, so you can automatically you can get the Q bar lah, because the Q bar is the inverted Q. But you have to make sure you can get the Q. So actually for the gated SR latch is the depend on the enable input. So you can see this one. Okay, next is the gated D latch. I think will be similar like SR latch, depends on the enable. Okay, enable input, but the D latch or we call the data or delay, so only one input lah. Okay, only the D input. Okay, so this is a symbol lah. So inside this one we have the logic circuit. Inside this one, this is a logic circuit for the gated D latch. Okay, then this is a symbol. Alright, symbol for D latch. Okay, and then this is the truth table. Okay, you can see this one. So when enable is a 0, this means no active. So either is a 1 or 0. Okay, so it's a similar, it's no change happen lah. So we will follow the previous. If the previous is a 0, so the current state will be 0 lah. If the previous is 1, so will be follow because of no change, so we will follow will be 1 lah. Okay, and then if enable is active, so will be D will be, if D is 1, so will be set lah. The Q will be 1. If D 0, okay, will be reset. Okay, will be reset. That is the operation. Just only this part. Okay, only this part lah. Just two operation lah. So either set or reset. Okay, depends on the D. If D is 1, so that means set. If D 0 will be reset, but depends on the enable input here. So enable input will be active high. Okay, active high, that means 1 lah. If the enable is the active low, that means this one will be active. Okay, 0 will be active. Compare than this one, we use the active height. That means the height, okay, the active will be 1 lah. Okay, so that is different. Actually, if you know when the enable is active low or active high, is follow the here. You can see this here. So this is called the active height. So if you have here, you have the bubble here. So for example here, so this one we call the active low. All right. So this one we call the active low. That means the active low, the output the active will be 0 lah. Okay, for example here. Okay, but if we have this one enable here, okay, enable like this. So the active height, this one we call the active height. This one we call the active low. So active height will be 1, active low will be 0. Okay. So this is a excitation table. All right, for the D. Okay, for the next, okay, this is we call the current state, and then this is next state lah. So for example 0 0, so the D will be 0. Okay, so 0 1, D will be 1. Okay, this is the input. Okay, and then if the 1, and then current next state will be 0, so the D will be 0 lah. And then 1 1, okay, 1 1, D will be 1 lah. So this is we call the excitation table for the next state lah. Okay, this is current state, for example Q, and then this is the next state for the next state for this Q, and then this is the input for D. Okay, so this is a Terminogram. To draw the Terminogram, I think we same before this. So you can see this one. So this one enable is the 0. Okay, enable is a 0. So the previous is a 0. So that's why here we put the 0 lah. Okay. So when this active, okay, enable is active here. So D is active. So that's why we put here 0. Okay. So that I mentioned to you. So suppose here will be 0. Will be 0. Then will be no operation lah. No operation. Sorry. It's no change. Okay, no change. That's why here we can get 1 lah. The value 1 here. Until for the next here, the 1 active, but okay, D is a 0 here. Okay, D is a 0. This means D 0 will be reset. Okay, that's why here will be reset. Okay, that's why the output here will be reset. Okay, but this one similar like before this. Okay, the enable is not active. Okay, it's not active here. Even this one D is 1 here. You can see D is 1, but the enable is not active. Still follow the no change lah. so follow the previous is the 0. Okay, and then this one will be active. Okay, enable is active, then B is the 1, so this one will be set okay, until this part. Okay, this part so the enable is not active, but the previous is 1. Okay, the previous is 1, not active, no change happen here, so this operation is not happen, no change happen, so will be 1 until for the next. Okay, until this one will be 1 until for the next here, so this one will be 1. Okay, and then the D will be 0, will be reset so that's why you can get here 0. Then this one will be active, D is a 1. Okay, and then will be follow okay, right, so 0 1 0. Okay, so based on this table you can draw the output for the Q. Then the Q bar will be invert the input Q. Okay, that is for the latch. So we have 4 types for the latch. Okay, we have the SR, okay, SR latch. Okay, we call the no latch. Okay, we have the NAND S bar R bar, and then we have the gated SR latch, and then another one we have the gated G latch. Okay, this some example Okay, some exercise. Okay, this one right. Okay, this one. Okay, this is still 0, not active, so follow the previous, we assume as a 0 here. Okay, before this we assume 0, this one also 0. Okay, this one 0, not active. All right, so now be active here. Okay, will be active here, so D is a 1 here, so automatically we can get 1. All right, so this one will be active. Okay, but the D is a 0. Okay, will be reset. Okay, that's why here will be get the 0. So because of enable is the active, but the D is a 0. Okay, enable is active, but D is 0, so will be reset So we reset will be 0. Okay, so and then this one no change happen. So this one the no change we call the no change. No, I put as a NC. NC is no change. Follow the previous, so that's why you can get 0 here, and then another one 0 here until for the next enable active, so will be 1 here. So enable 1 here, and then the D is 1, so that's why you can get 1 here. Okay, so this one active, but the D is a 0, so will be reset it will reset, and then still here. Okay, active, but D is a 0, so we reset. Okay, actually reset normally before this always reset, so just follow the previous is a 0, but the term is this one is a reset reset, this one here reset right. So now also 1. Okay, enable is active, and then this is 1, so that's why the output will be set so this one will be set as, and then active. All right, so the output will be 0. Okay, the D is 0, that means will be reset, so this one is the reset all right, I put as a R set, and then active R is 1. Okay, 1. Okay, one we call a set. Okay, and then this one not active so enable not active, so not active, so automatically even this one is a 1, so still follow the previous if a 0 also follow the previous, because of enable is not active, so will be follow the previous and so on. Okay, because of the enable is not active, so will be follow the previous we call the no change okay, we will follow the previous. Okay, so this is some exercise then you can try this one, and then for the Q bar just invert the Q. All right, okay, so this is some application of the latch. Okay, so you can see the application, simple application. They use the in the computer for input and output circuit so that's an example here. You can see we have the keyboard here. Okay, keyboard. Okay, they use keyboard S1 S2 until the SN. Okay, and then they use the input latch. Okay, this is computer, and then this is the output latch. Okay, and then this is for LED display Okay, so the SR and D latch is among the simplest and least expensive type of the memory element used in the logic circuit okay, because they use this one because of the okay, so the advantage of the SR and D latch because of the simplest and the not expensive, not expensive of the memory. That's why the SR and release is the most common use in the application. If you use the SR and the Latch lah, because of the simplest and the very cheap compared than others. Compared than use the, for example, uses the S bar, R bar, and then another one is the gated. Okay, gated SR Latch. Okay. All right, so next we go the flip-flops. Okay, they mentioned to you flip-flops and Latch actually is the basic storage element. It's the same like Latch. Okay, it's a basic. It's a almost similar. It's a basic storage. Actually, is a flip-flop and Latch is the basic storage element that operate with the signal level. Right. So for the flip-flop, ensure only one transition. Okay, for the flip-flop, we have two major types. Okay, first if you have the master and slave. Okay, master and slave, we have two stage. Okay, and then the output not change until the clock disassemble. Right, actually the master and slave depends on the clock, so the output will be not changed until the clock is the assemble lah. And then the another one is the H trigger. So the H trigger will be change happen when the clock level change lah, at the clock transition. So this one H trigger depends on the clocks. Okay. So next we go for one by one lah. Okay. First we go for the H trigger flip-flop lah. So this one you have to remember before this. So normally it's the synchronous. Okay, synchronous mean the output change state only occur at the trigger point that called the clock. Okay, so we have two type of the H trigger, and they can be positive. Okay, it's positive H trigger or negative H trigger. Sometimes they call the rising H trigger, or sometimes they call the falling H trigger. So you can see this one. This is we call the positive H trigger from 0 to 1. This we call the positive H trigger, and then this positive H trigger. So that means will be activated at this point. Okay. For example, this is the output. Okay, will be activated here. Will be activated at this point. Okay, activate at this point. Activate at this point. Activate of this point. Okay. For the negative H trigger, so will be activated at this point, and then for negative. Okay, but you can see the difference. So here, so that's why you can see the bubble here. So on the clock here, okay, so if no bubble, okay, no bubble here, all right, no bubble here, so that means this clock will be referred to the positive H trigger. That you have to remember lah. Okay, you have to remember this one. If no bubble here, okay, no bubble here, so we refer this this latch or flip-flop refer to the positive. You have to remember. So sometimes that's the question not mentioned. This is a positive H trigger. This is a negative H trigger. But you have to know. Okay, you have to know. So that's why you have to know. So for example, here, no bubble here. So automatically you know. So this is a positive H trigger. We have the bubble here. All right. Yeah, bubble here. So automatically we know this is activate on the negative H trigger. Okay, at the negative H trigger here will be activate at negative H trigger. Okay, so that is different between on the symbol. So that's why you have to know how to read the symbol actually. So this is the dimension to you. So that has the positive H trigger or negative H trigger depends on the bubble here. So if this one no bubble here, that means we will activate at the positive, and the bubble will be activate at the negative. Okay, negative H trigger. Okay, for the flip-flop, we have also 4 types of flip-flop. Okay, alright, so we have the SR flip-flop. SR is a set and reset, and then we have the D flip-flops, and then we have the JK flip-flops. Okay, and then we have the T flip-flop. T stand for toggle. Okay, T for toggle. The JK, I forgot the stand for what. Okay, today I will try to double check. Okay, I think this is a name Jason, and I'm not sure the JK stand for what. For the T is a toggle. Okay, D is the data or the delay. SR will be set and reset. Okay. Okay, for the flip-flop, we have 4 types. So we have the SR flip-flops, we have the D flip-flops, we have the JK flip-flops, and we have T flip-flops. Okay, so this is a symbol lah. You can see there's a symbol for positive edge trigger and negative edge trigger. So you can see this. You have to remember this one. Okay, so either this one is positive or negative. You have to remember the symbol here. So for example here, so we know. So this is a positive edge trigger. Will be activated at the positive. So this is our clock. Okay, so that means will be activated here. Okay, will be this point, this point, this point, and this point. Okay, will be activated. That means, for example, our output like this. Okay, will be activated like this. Okay, something like this. For this one negative, so will be activated. Okay, activate this point. Okay, will be activate this point, this point, this point, this point. For example, for the negative trigger, that means for the output will be like this. Activate here at this point. For example, okay. That's the difference between the positive edge trigger and negative edge trigger lah. Okay. So next we go for one by one. Okay. So we go for the edge trigger SR flip-flops. Okay. So you have remember this one. This is a truth table. Truth table for the SR flip-flops. Okay. So this one, if 0 0 X the clock either 0 0, there is no change. Okay, this is the truth table for the SR flip-flop. Alright, so if okay, R is the 1, okay, the clock will be positive. Okay, the positive is trigger. That means the operation will be reset lah. Okay, it will be similar like like latch. Okay, SR latch. And then if S is 1, okay, that means will be reset lah. Reset, the operation will be set. And then if the S1 R1 will be invalid lah. Okay, invalid. Okay, this one will be okay, will be follow the previous lah. Okay, invalid. Okay, this is a 0. Okay, this is 0. Similar like, okay, this one is similar like latch. Okay, so you can see this one, the example here. So first step you have to know. Alright, so the first step you have to know. So this one we use the positive edge trigger. So that's why you have to plot. Okay, you have to plot on the positive edge trigger lah. Okay, positive, positive, positive. That's why you can see. So that's why they put the line here on the positive edge trigger. They put on the positive edge trigger. Okay, you can see we put here. We put on the positive edge trigger. Okay, if this one have a bubble here, okay, so that's why you have to put on the negative edge trigger. So they activate on the negative edge trigger. Okay, for example, you have bubble. So now we don't have bubble, so we refer to the positive. Okay, you have to refer to positive edge trigger. Then you can okay, so before this is a 0. Okay, initial clock is a 0. That's why the output here will be 0. Okay, it will be until, okay, the clock will be active at this one. That's why here will be active here. Okay, now you can check there. Now we have 0 here and then 0 here. Okay, 0 0 0 0, no change. Okay, no change. So that's why this one will be follow the previous. Okay, this until this one follow the previous 0. Okay, so now will be activate at this positive edge trigger. Trigger, then you can see. So R will be 1, S will be 0, so will be reset. Okay, the operation will be reset. So now before this is 0, reset also 0, so will be follow the previous until for the next. Okay, the next active on the next positive edge trigger here. So the positive edge trigger here will be so this one will be 0, S will be 1, so will be set. So that's why you can get here 1 here until for the next. Okay, the next for until the next cycle lah. That is for the next positive edge trigger here. So the next positive edge trigger, this means 1, this one 0, this one will be reset lah. Okay, reset. This one will be reset. Okay, R until this part. Until this. Okay, so this one will be 0, 1. Okay, reset lah. So reset. This one will be set. Okay, until this one will be set. So this one 1. Okay, got 1. So this one 1. This one 0. So reset lah. Reset. Okay. Alright, so the Q bar will be invert the Q lah. So normally you have to know how to get the Q first, then you can get the Q bar lah. So normally the Q bar will be invert the Q. So make sure you have to know how to get the Q first. Based on this truth table lah. Based on this truth table. Okay. So the SR flip-flop is trigger pulse transition detector produce very short duration spike during the transition of the clock pulse lah. Okay, so this is some example simplified. Okay, so this is simplified logic diagram for the positive edge trigger SR flip-flops. Okay, so this one inside the flip-flop lah, the logic circuit inside the flip-flops. Okay, so you can see the short spike. Okay, normally you can the spike, actually the spike or the pulse you can monitor using the oscilloscope. You can see the pulse. Okay. Okay, so this is some example exercise of the SR flip-flop. Okay. Okay, you can see the first step that I mentioned to you, we refer to this one. So now we know we refer to the positive edge trigger. Okay, where is the positive edge trigger? So you have to put where is the edge trigger lah. Okay, for example here, I put here the edge trigger one. Okay, correct. Okay. Okay, you can use your ruler lah. So this one I just okay. Yes, this one is the positive edge trigger. Positive edge trigger. Okay, positive edge trigger and so on. Okay, so next maybe this one. Okay, another part you can try for negative edge trigger lah. This one positive edge trigger. Okay, this one focus on the positive edge trigger. This one will focus on the negative edge trigger lah. For example, here this is the this clock. Okay, so this is the negative. You refer to the negative edge trigger here. Negative figure, negative figure, negative figure, negative figure, some until so on. Okay, so now, okay, for example, like this. Okay, so this one, that clock will be 0, so now it will be 0 lah. Okay, no change. So set as a 0 here. Okay, so now clock is a 1. Okay, S1 are 0, so it will be set. Okay, will be set. So this one will be set. Set until this one, until the next, okay, the next clock lah. Okay, until the next clock will be active. Okay, this one. So S is a 0, R is a 0. Okay, 0 0, no change. Okay, no change, and no change is the, okay, I put this one will be set. Okay, this one will be no change, no change. So in the previous until the next state. Okay, the next. Yeah. Alright, so this one will be activate. Okay, 0 1. Okay, this means R will be activate lah, will be set. Okay, it will be reset. It will be reset. This one we call a reset. Okay, so reset will be 0. Okay, this one 0 1 1 0. Okay, the next, okay, active here. So 0 0. Okay, 0 0 0 0 here. 0 0, no change. So this yes, then no change. Yeah. Okay, it's a 0. Until the next. Okay, 1 0 1 0. Okay, will be set. Okay, this one will be set. So until the next, okay, 1 1. Okay, 0 0. Okay, 0 0 0 0, no change until the next. Okay, no change. So I put as the no change. This is a set. For example, no change. This is 1 1. Okay, so next here. So 0 0. Okay, 0 0 0 0, no change. So until for the next state. So this one also no change. So next state. Okay, you can try. Okay, next you can try lah for the complete, okay, for the complete answer. Okay, for example, like this one, I change to the, okay, I put this one as the negative H figure. That means we have bubble here. Okay, so on the, okay, on the previous, so you can ignore as the 0 lah. Okay, 0, because we activate here. We activate at this point, so at this point. So when activate this point, all right, so this is a clock 0. Okay, so this is a 0 0. Okay, 0 0 0 0, no change. So no change until the state. Okay, until the next state here is 0, no change. Okay, and then this one 1 0 1 0 1 0. Okay, will be reset. So reset, this one reset will be 0 lah. Okay, until the next. Until the next. Okay, one 0 0. Okay, 0 0 will be no change. Okay, until this one. Okay, 1 0 1 0 1 0 will be set. So will be set. Okay, this one will be set. Okay, for example, okay, this one will be set, and then this one will be 0 0, no change. No change. Okay, so this one, okay, 0 1, okay, will be reset lah. Will be set until this one. Okay, until it will be reset. Will be reset. Okay, so next we can try okay, to get the complete. Okay. Right, so next we go for the H trigger D flip-flop. Alright, so first you can see the symbol here. Alright, so the symbol we use the positive. That's why you can see here we refer to the positive H trigger here. Okay, so the flip-flop, actually the D flip-flop is a similar like the latch. Okay, the latch. Okay, so if the D is 1, so it will be set. Okay, if the D is a 0, it will be reset. But on the set and reset depends on the positive H trigger or negative H trigger. So this one refer to the positive lah. Okay, because of the symbol is the positive. But if this bubble here, okay, so this clock will be activated at the negative H trigger. So depends on the symbol here. Okay. For example here, okay, so clock is a 0. So this one automatically will be 0. So now clock is 1 here. Okay, so the D is 1. That's why you can get here D. And then clock this one will be follow until the next. Okay, the next. Okay, so this one, okay, activate, but D is a 0. So that's why here will be 0 lah. Okay, this one will be reset. This one will be set. Okay, this one will be follow. Okay, until this one. Okay, so now this one, so now is set lah. Okay, and so on. Right, so this some exercise that we can try. You can try this one. I think will be same. Okay, okay, this one first you can. This is a positive H trigger, and this one they use the negative H trigger lah. Right, so this is the result. You can double check is it correct or not correct. So you can double check the answer here. So already here already give the answer, but you have to double check lah, is it correct or not. Okay. And then for the JK flip-flop, okay, for the JK flip-flops, so this is a similar like the latch. Okay, this is a truth table. Okay, so this is a symbol for positive JK flip-flop. Let's mean here we refer to the positive H figure. Okay, I think will be same. Similar like latch. Okay, so if JK, okay, this is almost similar like SR lah. Okay, but this one will be if J0, K0, this is no change. Okay, but if you activate the K, alright, so will be reset. Okay, but if you activate the J, so will be reset. And okay, and if you 1 1, okay, 1 1 will be, we call it toggle. Okay, so what is the toggle? Toggle that means invert the input. For example, or invert the previous. Okay, invert the input lah, or invert the previous. for example, the previous is 0, so the output will be 1. So if the previous is 1, the output will be 0. Will be invert the input lah, or invert the output. Okay, the toggle. Okay, that we call the toggle lah. Okay, you can see this here. Okay, so this is a toggle lah. You can see. So 1 1. Okay, so this is 1 1. So 1 1 is a toggle. So the previous is a 0. So that's why is a toggle will be 1. Yeah, that's why we 1. Until this one, until we be at the next positive edge trigger here. So that will be 0 0. So 0 0, no change. So no change will be follow the previous. So yeah, we follow the previous. Previous is 1, so this one will be follow the previous until the next state. Okay, the next positive edge trigger. So 0 1 0 1. Activate at the K, so we reset. So this one will be reset 0. Okay, and then this one will be set. Okay, 1 0. So set until so on. Okay, so that is the JK flip flops lah. Okay, JK flip flop for Terminogram. This one we call the Terminogram, right, for the flip flop. And then this one is a similar like before this on the SR flip flop or SR latch. Okay, so we have we call the execution table for the next state. For example, here Q for the next Q. Okay, for the next state for the Q, for example 0 0 0. That means our JK possibility of the input will be 0 or X. Okay, X. This one can be don't care lah. We can call as a don't care as the 1 or 0. Okay, and then for Q is the 0, and then next Q will be 1. So the input can be 1 and X. Okay, J will be 1 and K will be X. Okay, X that means you don't care lah. So and so on. Okay, this means you have to remember this also, the excitation table lah. Normally, I think for the before this will be given lah for the final for the final. But because of this semester also is the online, okay, online final exam, so we don't provide any table for extension table, but you can refer the notes lah for the extension table, for the truth table. Okay, okay, there is some example, some exercise. Okay, you can see this one. So first, maybe you can use the boss. Okay, so you can use. Okay, so this one, okay, you can see here 0. Okay, so this one will be 0 lah. Okay, and then until this one, okay, deactivate. Okay, 0 1. Okay, 0 1 will be reset. So reset. Before this already reset, so this one will be 0 lah. Okay, and then until deactivate this one. Okay, 0 0 0 0 will be no change. So that's why we get no change here, and then so on lah. Okay. Alright, so this one I think you have to try on the negative edge trigger. So try here at the negative edge trigger lah. I think on this part. Okay, so to put on the negative edge trigger. Okay, so this one first you have refer to the positive edge trigger. Second, you have to refer to the negative edge trigger. So you have to double check here. Okay, on the negative edge trigger. Okay, so next for the edge trigger, T flip-flops. Okay, the T flip-flop, I think similar like D flip-flops. Okay, we have only 0 or 1. Okay, for example, if 0, no change. Okay, no change. If 1, toggle. Okay, toggle. That's why T we call the toggle lah, toggle flip-flop. Toggle we invert lah. Invert the previous. For example, previous is 0, so will be invert will be 1 lah, or 1 will be 0. Okay, for example, like this one. So you can see the Terminogram here. Okay, the first step you have to know. So we refer to the positive trigger. So that's why you can put the line on the will be activate at the positive trigger lah. Okay, will be activate at the positive trigger. Right, the previous is a 0 because of the clock is a 0 here, and then okay, so the clock will 1 activate. Okay, the T is 1. T is 1 will be toggle. toggle will be invert the previous. So previous is 0, so that's why it will be 1 here until for the next state. Okay, the next state, okay, this one will be activate, but T is a 0. 0 will be no change, no change. The previous is 1, so no change here. Okay, will be follow the previous lah. No change, follow the previous is 1. Until this one also no change. No change, follow the previous. Okay, until this one, you can activate at this next state will be T will be 1 lah. 1 will be activate, that means will be toggle lah. So before this 1, so will be 0 until for the next. Okay, the next also will be activate the toggle. So toggle will be invert the previous, will be 1 here. Okay, that is for Terminogram for the T flip-flop. Okay, T flip-flop. Okay, so maybe you can try this exercise. Okay, all right. Okay, already give the answer here. All right, so you can double check lah, double check. So first you can plot on the positive figure here, positive figure here, positive figure. Okay, so this one is not active, 0. Okay, so 1, if the T is a 0, so no change. Okay, so this one we call the no, see no change. Okay, this one 1, and then the activate is a toggle. This one we call T, toggle is 1. Okay, until this one will be 0. Okay, this is a T, this is 0, no change. Okay, and put as a no change is a 1. Okay, follow the previous until this one, okay, 1, and then toggle will be 1, so will be toggle. So before this is 1, so automatically will be 0. So I put here as a toggle. Okay, and then until this one, the T is 1, so will be toggle. So this one also toggle. So we 1. Okay, and then this one also toggle. Okay, toggle here, so will be invert the previous 0. Okay, similar like this one. So this one. This is positive H figure, and this one is the negative H figure. That's why you can plot here. You can plot at the negative H figure. So at this point, and this point, and so on. Okay. That's why first you can try the positive H figure. Next you can try the negative H figure. So this is the answer. You can double check is it right or not. Okay. So next is the exercise. Okay, exercise Latch and flip-flop exercise. Okay, first here. All right, so we have the draw the output waveform for the JK flip-flop. Okay, this is we call the JK flip-flop. You have to know the JK flip-flop, the truth table for JK flip-flop, and we have the gated. Okay, gated D-latch. Okay, D-latch. So we have to we have the flip-flops and we have the latch lah. Okay, you can get the base. It's similar. Okay, first you can solve the from the JK. Okay, from the JK. So we know. Okay, for the JK, we know we use the positive figure. Okay, this one because no bubble here, so you can put it here. So on the positive. Okay, positive figure, positive figure, positive figure, positive figure. Positive figure, okay, until so on. Okay, and the positive figure lah. All right, so for the JK, all right, so the clock, okay, will be 0. That's why here will be 0 lah. Okay, T naught. This one T naught is a T naught bar. Actually is a Q bar lah. So this one is represent as a bar actually. Okay, so just focus on this one lah, the Q there. So that's why you have to find the Q naught here. Q naught, then you can get the D. Because the D here, the input for the D actually is a output for the JK from the JK flip-flop. Alright. That's why you have to find the JK flip-flop, the output for JK flip-flop, then you can find the output for the Q1. Okay. Because the input for D is depend on this one. Okay. Alright, so for next. Okay, next, okay, 0, 0 is also 0, and then activate here 1. Okay, 0, 0, no change. Okay, no change until the next. Okay, next is 1, 0. Okay, will be set. Okay, will be set. Okay, and then so on. Okay, and then this one, this Q, okay, Q1. All right, so actually it depends on the D. Okay, and also enable lah. So enable, enable. You can see this one, enable and clock is the same. That means will be activate at this, okay, at the this one, at the this position. Okay, activate at the one lah. All right, at the one. So that's why you can get here. So the Q1, that's why you can get here 0 and then 0 and then also 1. Okay, so this is the 1 because of this one is the 1 here and so on. Okay, that's why you can try this one. Okay, you can continue lah. You can continue this one. To get the, you can double check is it the correct. So normally we have give the answer here, so you can check whether this waveform is correct or not. So this is a example for the, we have combination between the JK flip-flop and the D latch. Okay, so first you have to solve the flip-flop here because we have to find the output here because this output will be input for the D. Okay, for the D, and then to for example here, so normally the clock here actually will be same with the enable input. So this is also can declare as the enable input lah because of will be same. Okay, sometimes it's a depends enable input. Sometimes you can not follow the clock lah. For this case, the clock and the enable will be same lah. We follow the same. That means will be for the enable will be activate at the at one when the enable is active. Okay, all right, so that's all. I think I will stop here for until the okay, until the flip-flops. Okay, this is the okay, this is the master and slave flip-flop. I think I'll stop here. So this is for the we will cover for the next week. Okay, for tomorrow. Okay, for tomorrow I will share the as usual. So I will share the video for the tutorial 3. Okay, tutorial 3 is the combinational logic circuit. Okay, on the YouTube tomorrow, on the tomorrow morning. So you can watch lah. After you watch, please write your name. Okay, write your name. So as your attendant for today. Okay, so I will stop here for today. So because of already half an hour, I think we stop here. Too many topic will be covered for today. So we have the 4 type of the latch and then 4 type of the flip-flop lah. Almost the latch and the flip-flop almost same. Okay, same concept lah. Because the both actually is the basic storage element lah. Okay, the latch and the flip-flop is the basic storage element. Okay, so before I stop here, so let remind for the group assignment here, right? So currently we have seven groups. So suppose I think we have the 8. Okay, we have the 8 group lah. So maybe we have left another 1 group lah. So today you can give your name, and then also for the group number 5, 6, 7. Please make sure give your title lah, your choose your question question number 1 until number 6. So currently we have the question number 1, 2, and 3 and 4 already taken by group number 1 until 4. So we have 5 and 6. Okay, then we can rotate lah. Okay, then the rest we can rotate. Okay, we can rotate 1 and 2 or 3. So okay, only 1 and 2 lah. This means okay, first all the question will be taken, all the groups, okay, from question number 1 until number 6. Then we rotate to question number 1 or question number 2. Okay, because of we have 8 group. Okay, so after this, please please give your chosen your choose of the title so which question you want to answer. So you can start. Okay, hopefully you can start early lah. So the due date for this assignment is the next one. So I think we have another almost 1 month. Okay, 1 month from now. So the some of the group already started last week, so that's good. Okay, so some of the group already used the Proteus. Okay, up to you. So I'm not sure. So because of long time I'm not handle the lab for the year 1 or year 2. before this I'm not sure. So before this we use the multi-sim, okay, multi-sim software to or you can use the Portals, or you can use the Flipflops, or you can use the Portal, or something, some software that you can use to run the digital circuit lah. Okay, so I think that's all for today, right? So I will stop here until the latch and flipflop exercise. So next we can try lah the exercise.
Doctor,
Yeah.
I have a question.
Yes.
Can we choose the same number another group has chosen, or we choose a different number?
Okay. You have to now you have to choose the difference. Okay, you have to choose different because we have still available topic number 5 and number 6. Then
Okay.
after the all the title will be chosen. Okay, then you can select lah which one. But normally you have to rotate on the question number 1 or question number 2.
Okay, thank you, Doctor.
Okay, all right.
Yes,
Okay,
thank you, Doctor.
Okay, welcome. All right, so if no question, I will stop here. So then you can WhatsApp me to update your title. Okay, your question number that you have choose. Okay, right. So tomorrow, don't forget. It's just watch the YouTube video for the tutorial 3. Yeah, for the tutorial 3. So still, I'm not the tutorial 3. I just cover for question number 1 until question number 8. Okay, and then the rest you can try lah. I think we have for tutorial 3 we have 12 questions. So question number 9, 10, okay, 11 and 12, so you can try by yourself. If you have any question, you can ask me lah. So on the video on the cover for question number 1 and question number 8. Okay, for the tutorial tomorrow. So don't forget your tomorrow based on attendance, based on the comment lah. You have to write your name. Okay, and then I will take the attendance based on the comment lah. Okay, so it's no question. I will stop here. Okay, thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Okay, welcome.